Here's a task that I picked for devlog 2. I started off in Blender with rigging, also coloring the model, sort of doing a UV mapping to a texture palette. There's a guy named Infencia, I think it is. I'm probably butchering that. He has really good tutorials on that. Then creating the animations in Blender. I created 3 of them, and then started the coding tasks. First task was computing the skinning matrix. From there, using the palettes and the UV coordinates to actually render the colors on the model, creating a game loop, and doing some refactor of the entity component system because I had a Rust problem. Well, actually, it's not really a Rust problem, it's more of a me problem. And then actually playing the animations in the game. Most of the time I spent in the GLTF 2.0 specification along with this image. So the first task, as I mentioned, was related to skinning. So learning on how the data is represented, how to parse it in, and how to traverse the hierarchy of joints. In this case, those joints are actually part of this node section, and essentially going through and computing the global transforms of each of the joints, which can then be used in this section over here to actually create the matrices that's passed into the shader to actually handle which joints and which weights affect the vertices in which ways. But it wasn't all sunshine and rainbows. I had quite a few problems with the skinning, as you can see with this and this and this and this and this. But finally, oh no, this one too. But finally, I figured it out. So after the skinning, I wanted to get rid of that flat red color that I was currently using. And so I used the palette that I had created and mapped the texture coordinates and rendered that, which has to do more with the materials, as that's where the texture is actually coming from. I'm not using any of the PBR data. I think in the future I would like to write a shader to handle that. Currently it's just sampling the texture with the provided texture coordinates. Here's the color palette that I made, and I did this in GIMP, and there's a really good tutorial on that. And from this color palette, I have a few colors that I'm using, but this is all, programmer art, so in the future it'll change. I had one slight problem with the texture rendering, which was I forgot to enable depth testing. After that, the texture rendering worked fine, and it was time to start finally working on the animations. The animation section is located over here. So the first thing I started to do was to look at the data and see how it was laid out. And at first it looked a bit complicated, but staring at it enough time, it started to make sense. So the channels here point to specific nodes, which in my case are joints or bones, and you can use them interchangeably. It also points to a sampler. A sampler has an input and an output, and also has a type of interpolation, which in my case was only linear. The input are the keyframe times, so that would be this section here, and the output are the keyframe values. So in this case, if you look at this as a translation, this value here is the translation at keyframe 0.8 seconds. So in their example, they give 1.2 seconds of global time. You need to pick the 0.8 and the 1.6 second keyframes and interpolate between those two. So the translation and scale are vec3s, and you would use linear interpolation, at least in this example. But the quaternions, you need to do a bit of slurping. After we have the correct interpolated value, we need to use that to update the local transform, which would then trigger the updation of all the global transform for the children. Once I had the data parsed and I understood how to update the global transforms to do the animations, I started working on an animator. But as soon as I started writing the animator, I had an issue. Again, this is more of a me issue than a Rust issue, where the borrow checker was unhappy, as we can see with the code here, that I was doing a mutable borrow and then a mutable borrow after. What I didn't understand was that these functions actually point to completely different sets of data on the heap, but I guess the compiler didn't get that far. So to fix this, I went with a more data-oriented approach. After these last few weeks, I've definitely learned a lot more about Rust, but I'm still not an expert. So I'll be running into more and more things like this, I assume. When I had the animator finally written, when I ran it, nothing happened at first, but then a little more tweaking, I ended up with this. I had a few other problems, but once I got the animator working, you can see this is the idle animation, this is the dancing animation, and this is the run animation. And as you can see, I left the noodly legs. For next week, or next devlog I should say, I'll probably be working on lighting and shading. Thank you for watching. Take care.